everyone, I hope all of you are doing good, and today I am here with a video on class 8 maths linear equations. In this video we are going to learn about what are linear equations, why do we even need them, in fact do we really need to learn about them? Yes, we do. Not just that, we will also learn how do we solve these linear equations, and then we will also look at some of the applications of linear equations. So I would request you to watch all the videos of this playlist so that you get complete clarity and a crystal clear understanding on linear equations. Let's get started.
So let us first think of a scenario or think of an example from something around us. Let's say that you have 5 candies with you, or you have 5 chocolates or 5 toffees with you, and you knew that there are total 7 candies in your home. So the remaining candies are with your little brother. So now if I ask you how many candies are there with your little brother? Now the question might sound very simple here, but can you tell me a proper method by which you can prove that how many candies are there with your little brother? So maybe we can go with an approach like this, that let's say that the little brother, he has X number of candies. So if he has X number of candies, and how many candies do you have? You have 5 candies. And what were the total number of candies at your home? Total number of candies were 7. So when you look at this equation, what do you see? You see that this equation exactly satisfied the scenario, because the scenario says that the elder brother has 5 candies, the younger brother has how many candies we don't know, but there were total 7 candies in the house. So as per that, x plus 5 is equal to 7, where x is the number of candies with your little brother. So if we solve this equation, so this is what we call as an equation. So this is an equation, and if we solve this equation, so solving an equation basically means finding out the value of x. So if you try to solve this equation, you get the value of x as 2, which shows that the little brother has 2 candies. So basically what did we see? We see that in such scenarios of day-to-day life, we need equations. And that is why we are learning about linear equations. Now what exactly are linear equations? We will get to know that in some time. But basically this was a very simple example. Like when I told you that there were total 7 candies and the elder one had 5, you could have very easily calculated in your mind that the little one would have 2. But there has to be a method, because not every time the scenarios are so simple. So sometimes there are situations where complex calculations are involved. So that is why we have these equations in place, so that by solving these equations we can solve such complicated problems of our lives. So here this entire thing is called equation, and when you look at only this part, that is x plus 5, this is nothing but an expression. Now again you might wonder how are expressions and equations different. So please do not worry, we will learn about each of them in a lot detail. So this slide was just to tell you that why are we even talking about equations, or why are we talking about solving an equation? Because we need them to solve the daily problems that we face. So let's now talk about expressions and equation. So when we talk about expression, what it is basically a mathematical phrase with numbers, variables and operators. Now till now you might have heard about the term phrase mostly in your English grammar. We talk about phrases in English. Now in mathematics also we have phrases. Now what do we mean by phrases? Phrases are nothing but when numbers, variables, operators, they all combine together. So they form phrase. Something like this. Let's say that we have something like 3x plus 5. So here 3 is a number, x is a variable, plus symbol is an operator, and 5 again is a number. So this is an example of expression. Similarly, when you look at 4x squared, this is also an expression because it has numbers as well as variables. You look at 5 plus 9 minus y. This is also an expression. You talk about x squared plus y plus z. This is also an expression. So there are no fixed number of constants, there is no fixed number that there has to be these many numbers or these many variables or these many operators, but wherever you see a combination of these, so that represents nothing but an expression. Now in mathematics we have a specific branch called algebra which deals with symbols and rules for manipulating those symbols. So that is where we talk about these algebraic expressions. So these are also called algebraic expressions. Now let us talk about equation. Now the word equation itself has this word equation, so which has come from equal. So it actually talks about equality of something. So equation is always a statement of equality of two expressions. Now when you have two expressions and you have an equality symbol in between, what does that try to show? For example, if we take 3x plus 5, which as I said is an expression, is equal to 1. So now this is no more an expression, it became an equation because you have this equality symbol. Now when we have this equality symbol, what are we trying to say? We are trying to say that the entire expressions 3x plus 5, its value is equal to 1. So that is what we are trying to depict out of it. Similarly, when you look at this, 4x squared plus 2 is equal to 3x. So here also if you say this is an expression, similarly this is also an expression, but since there is an equality sign connecting the two, so overall this is an equation. You can have equations of many different forms, many different types. For example, x minus y by x plus y is equal to 42. This is also an equation. If you say 5x is equal to 0, that is also an equation. 7y is equal to minus 9. So there could be n number of examples for equation. But what we want to emphasize is whenever we talk about equation, there has to be an equality symbol which equates the left hand side and the right hand side. Now normally as we move ahead, you will see that anything that lies on this side of the equation is written as LHS, that is left hand side, and this side is RHS. So for any equation, LHS has to be equal to RHS at any point in time. So this is the difference between expression and equation, because a lot of times children remain confused that whether they are the different or they are the same thing, or if they are different then how are they different. So all these things need to be understood at the beginning itself. So now that we have spoken about equations and expressions and we talked about numbers, operators, variables, so let us talk about constants and variables. Now in mathematics, when we talk about these algebraic equations, expressions, etc., we often come across many different types of numbers, variables, operators. So let's very clearly understand the difference between constants and variables. Now when we talk about constants, the word constant means fixed, something which doesn't change. So constants are those figures which have fixed values. That is, let's say when you say 2, so what is 2? 2 is always 2. So whether you talk about 2 apples or you talk about 2 fingers or you talk about 2 friends, so the number 2 always signifies the same value. Similarly, when you talk about any number, you think of say 2, 5, 9, 200, minus 65. So these are all values and their value remains the same, doesn't matter where they are. So even if you say that, even if you put them in an algebraic expression, for example, if you think of an algebraic like x plus 5 is equal to 9. So even here 9 would always mean 9, 5 would always mean 5. So they will not change their value at all. So they are constants. Whereas when you talk about variables, the word itself has vary. So they have varying values, they have changing values. So their values changes depending upon where they are. So again, let us look at some example. So let's take the same example of the expression, that is x plus 5 is equal to 9. Now here, when you look at the value of x, what would be x? X in this case would be 4, right? Now let's say if I take up some other equation. Let's say we take another equation, x plus 1 is equal to 2. Now in this equation also we have x, in this equation also we have x, but here the value of x would be 1. But here the value of x is 4. So the same variable might have different values in different equations. Similarly, if we think about an equation like this, x plus 5 is equal to y. So here the value of 5 always remains the same. But if we take x is equal to 1, in that case what happens? Y is equal to 6. If x is equal to 2, then y is equal to 7. So you see the value of x and y, they keep changing. They are dependent on each other, but their values keep on changing. So these are called variables. Now variables are normally denoted by alphabets like A, B, C or X, Y, Z or P, Q, R or whatever. So that's how we denote them. Now when we are going to talk about these expressions like the linear equations, and when we are going to solve them, so what we are going to do is we are basically trying to solve that equation by finding out the value of the variable in that equation. So normally the variables are represented by alphabets. So now let us try to understand what exactly is linear equation in one variable, because that is what we are going to deal with in this lesson. Now, as the name says, linear equation. Linear equation means, why is this equation linear? Because the highest power of the variable in this equation is 1. So what do we mean by that? So let's take an example. So let's take this example. 4x plus 2 is equal to 35. So here what happens? The highest power of this variable, that is x. So here when you look at the variable, which is the variable, that is x, and what is the power of the variable in this case? The power of the variable is 1. Do we have any other variable? No. So that means the highest power of the variable in this equation is 1. Let us look at few more examples. So let us take this example. 5 by 4 into x minus 4 is equal to 0. How many variables do we have? 1. That is x. What is the highest power of x? That is 1. So here also the highest power of the variable is 1. So this is also a linear equation. Let's look at yet another example. X square plus y square is equal to 1. So in this case, how many variables do we have? We have two variables, that is x and y. And what is the power of the variable? For x also it is 2, for y also it is 2. So which is the highest power of variable in this equation? That is 2. So is this a linear equation? No, this is not a linear equation. Similarly, if you look at this example, x to the power 5 minus 2x is equal to 1. So here you have only one variable x, but at this place it has 1, but at this place the power is 5. So which is the highest power of variable in this equation? That is 5. So is it a linear equation? Not again. Now if you look at this example, 1 plus z by 1 minus y is equal to 40. So here you have two variables y and z, and the highest power involved is 1. Therefore this is again a linear equation. So like this we can decide whether a particular equation is a linear equation or not. Now when we say linear equation in one variable, that means that equation should have only one variable. For example, here this equation has one variable. This equation also has one variable. This equation has two variables. Anyways, it is not a linear equation, but it doesn't have one variable also. Similarly, this equation is a linear equation, but this is not in one variable. It has two variables, y and z. So in this lesson we are only going to talk about equations which are linear as well as which involves only one variable. So now the next important task that comes into picture is solving a linear equation. Now what do we mean by solving a linear equation? It is about finding out the values of the variables for which the left hand side and the right hand side would be equal. So those values of variables are called solutions of the equation, and by finding out those values we say that we are solving a linear equation. So let us take an example. So let us say we take this linear equation, 4x plus 2 is equal to 35. Right? So this side is LHS and this side is RHS. Right? Now this LHS, because for RHS the value is 35, which is going to remain constant for always, but for left hand side the value of x is not known, but there will be certain value of x for which the left hand side will be equal to right hand side, because the question has told, or the equation itself says, that the value of x should be such that this relation holds true. Right? So how will we solve this equation? So now whatever we do in order to find the value of x, we always need to ensure that at every step LHS should remain equal to RHS. So let us say, so if we want to subtract something, add something, we have to do it on both sides so that the balance is maintained. Right? So here what we do is, let's subtract 2 from both sides. Now what happens? Now let's say that if on one side we had 100 kg apple, the other side also we have 100 kg apple. Now if we want to ensure that on both sides apple should be 100 kg. So if you are reducing 2 kgs from one side, you will also have to reduce 2 kgs from the other side. It is just like that. So when you subtract 2 from both sides, what happens? This becomes 4x plus 2 minus 2, and this becomes 35 minus 2. So here plus 2 minus 2 cancels out. So we get 4x is equal to 35 minus 2. So 35 minus 2 is nothing but 33. So we got the value of 4x, but we want the value of x. So for that what we can do is divide by 4 on both sides. Again, when we are dividing on both sides, the equality is maintained. So what happens? 4x by 4 is equal to 33 by 4. So therefore, what happens? X is equal to 33 by 4. So we are able to find out the value of x for which this equation holds true. So x is equal to 33 by 4 is the solution for this linear equation. So this is how we found out the value of x. Now if you want to verify that, okay, is it true that if we put the value of x as 33 by 4 in this equation, that the relation will hold true? So let us try to do that. So let us put x in LHS. So the left hand side will become equal to 4 into 33 by 4 plus 2. So that will be 33 plus 2, which will be equal to 35, and 35 is nothing but RHS. So that means by putting this value of x, we can see that LHS is equal to RHS. So therefore, this is the right solution for this linear equation. So now we will talk about some tips to solve linear equations quickly, because here we saw that we multiplied on both sides, we subtracted on both sides, we divided on both sides. So let's see, let's look at some tips so that we can do all these operations very quickly. So the first thing that we need to remember is, whenever we are transposing a positive number from left hand side to right hand side, or from right hand side to left hand side, the sign changes. That is, a plus 9 becomes a negative 9, a negative 9 becomes a plus 9. So let's look at this example. So let's say if you have something like x plus 9 is equal to 0. So right now plus 9 is on the left hand side. The moment you transpose it to the right hand side, the plus 9 becomes minus 9. And the same thing holds true when you move it from right hand side to left hand side. Let's say, had it been something like this, 0 is equal to x plus 9. In that case, maybe you would have transposed 9 from right hand side to left hand side. So in that case, it would have been minus 9 is equal to x. The second thing is, transposing a negative number from LHS to RHS makes it positive, just the opposite thing. Let's say instead of this, had it been something like 4x minus 9 is equal to 44. So in that case, it would have been something like 4x is equal to 44 plus 9. So you see, the minus 9 when moved to the other side became a plus 9, and the same is true for movement from RHS to LHS as well. Now when you are transposing multiplied by 9 from LHS to RHS, it becomes divided by. Like let's say if you have something like 4x is equal to 44. So in this case, if you are trying to move this 4 into to the other side, then it becomes divided by. So 44 divided by 4. So the 4 from numerator comes to the denominator on the other side. Now, do you know why is this happening? That's because it is nothing but as if you are dividing both sides by 4. So if you divide both sides RHS and LHS by 4, you will get the same thing. So just to simplify it further while calculating, we remember these tips so that they help us to solve the equations faster. Similarly, when we transpose divided by 9 from one side to another, it becomes multiplied by 9. Something like x by 4 is equal to y by 2. So in this case, if we take this 1 by 4 to the other side, it becomes 4 into y plus 2. So this is how we can solve linear equations very quickly. So let's see how do we solve linear equations with numbers on one side. So where you will have variables on one side and numbers on the other side. So let's take an example. Suppose we took this example, 17 plus 6p is equal to 9. So if we take this example, so how are we going to solve this equation? Solving this equation means finding out the value of p for which this equation will hold true. So what we do is, our first motive is to collect all the variables on one side and all the constants on the other side. So here you have one constant on this side, the other constant on this side. So what we do, we'll collect the variables on the left hand side and we will keep the constants on the right hand side. So therefore we moved 17 from left hand side to right hand side, so it became minus 17. Therefore 6p is equal to minus 8. So therefore, what would be p? So this would be equal to 2 4s are 8, 2 3s are 6. So this would be minus 4 by 3. So for a value of minus 4 by 3, this equation would hold true. So this is how we solve it. Now in a similar way, we will move ahead and we will try to solve as many equations as we can. So let us quickly look at some of the simple equations. Question number 1. Solve y plus 3 is equal to 10. So as I said, our motive always would be to keep the variables on one side. So let's keep y here and let's take my 3 to the other side. So it became minus 3. That is equal to 7. Therefore y is equal to 7. Question number 2. Solve 3 by 7 plus x is equal to 17 by 7. So here also the same thing, let's keep the variable here, that is x, and let's transpose the constant to the right hand side. So we get this, so therefore this would be equal to 14 by 7, now 7 2s are 14, so x is equal to 2 would be a solution for this equation. Question number 3, solve 2x by 3 is equal to 18. So 2x by 3 equals to 18. So here again, let's try to move the constants one by one. So 1 by 3, when it goes this side, it becomes into 3. Similarly, if 2 from here goes to the other side and it goes to the denominator. So this would be 2 9s are 18, 9 3s are 27. So x equal to 27 would be a solution for this equation. Question number 4. Solve 1.6 is equal to y divided by 1.5. So here let's bring the constants on the left hand side and let's keep y on the right hand side. So 1.6 into 1.5 is equal to 2.4. So 2.4 is equal to y, therefore y is equal to 2.4. Question number 5. Solve 14y minus 8 is equal to 13. Here again, let's take the constants on the right hand side. So 8 moves this side. So we get 14y is equal to 21. Or y is equal to 21 by 14. So 7 2s are 14, 7 3s are 21. So y is equal to 3 by 2 would be a solution for this equation. Question number 6. X by 3 plus 1 is equal to 7 by 15. So here again we'll keep x by 3 on this side and we'll move the constants on the other side. So 7 by 15 minus 1. So here if you take the LCM, this would be 7 minus 15. So here x by 3 would be equal to minus 8 divided by 15, or we can say x is equal to minus 8 into 3 divided by 15. So 3 5s are 15, this is equal to minus 8 by 5. So x is equal to minus 8 by 5 is a solution for this equation. So let us now try to solve linear equations with variables on both sides, because till now it was quite simpler when you have constants on one side. Now if you have variables on both sides, then how do you go about it? So let us take an example of this type of an equation which has variables on both sides. So let's consider this. 5x plus 3 is equal to x plus 10. So you have variable here, you have variable here. So how do we handle this? So again here also we will follow the same trick. We will try to collect all the variables on left hand side. We will try to send all the constants to the right hand side. So for that what we would do, 5x minus x. So this x would have come this side and this 3 would go this side. So this would become 10 minus 3. So 5x minus 1x would be 4x. 10 minus 3 would be 7. So therefore x will be equal to 7 by 4. So this would be a solution for this equation. So you see the approach remains the same. It is just that you need to remember those simple steps when you transpose constants and variables from one side to another. So here what we are going to do is we will arrange all terms with variables on one side and we keep all the constants on the other side. So that is the simple mantra that we will follow to solve linear equations. So let us look at some other examples. So let's say you have an equation 5t minus 3 is equal to 3t minus 5. So here also we will send the variable here, we will send the constant here. So we get 5t minus 3t is equal to minus 5 plus 3. Or we can say 2t is equal to minus 2. Or we can say t is equal to minus 2 divided by 2. Or this is equal to minus 1. Therefore t is equal to minus 1 is a solution for this equation. So keeping these points in mind, let us try to solve some more equations with variables on both sides. Question number 1. Solve 4z plus 3 is equal to 6 plus 2z. So in this case, we collect all the variables on one side and the constants on the other. So we get 2z is equal to 3, or we can say z is equal to 3 by 2. So this is a solution for this equation. Question number 2. Solve x is equal to 4 by 5 into x plus 10. So in this case, what are we going to do? So what we will do is to make it simpler, because due to the presence of 4 by 5, this equation is like looking a little different. So what we will do is we will send this 5 on this side so that we do not have this complexity of having a denominator extra. So what happens, this becomes 5x is equal to 4x plus 10. So now we will follow the same approach. So let us first find out the variable and the constant terms separately. Like here we have done 4x and plus 40. So now let's bring the variables on one side and the constant on the other. So we get x is equal to 40. Question number 3. Solve 2x by 3 plus 1 is equal to 7x by 15 plus 3. Here again the same thing. Let's bring the terms with x on left hand side. So it is 2x by 3 minus 7x by 15 is equal to 3 minus 1. So here 3 and 15, the LCM would be 15. So this would be 10x minus 7x and this would be equal to 2. So this is 3x divided by 15 is equal to 2, or we can say 3x would be equal to 2 into 15, or 3x is equal to 30. Therefore we can say x is equal to 30 divided by 3. So 3 tens are 30, so x is equal to 10 would be a solution for this equation. Question number 4. Solve 2y plus 5 by 3 is equal to 26 by 3 minus y. So here again 2y plus y is equal to 26 by 3 minus 5 by 3. So this becomes 3y is equal to 21 by 3, or y is equal to, here 3 7s are 21, so this would be 7 and this 3 will come here, so it will become 7 by 3. So y equal to 7 by 3 would be a solution for this equation. Question number 5. 3m is equal to 5m minus 8 by 5. So here again we bring all the m's on left hand side. So this is what we get. Now 3m minus 5m would be minus 2m is equal to minus 8 by 5, or m would be equal to minus 8 by 5 into 1 by minus 2. So 2 4s are 8. This minus and minus will also get cancelled. Therefore, m is equal to 4 by 5 is a solution for this equation. So let us now move ahead with the next type of equations that we will learn to solve. So these are equations which are reducible to linear form. So here the equations would still be linear equation, but they will not appear in the same conventional form of linear equation. So the way they will appear to us would look complex, but we will see how we can reduce them to the usual form of linear equation. So whenever you find an equation of this form, where you have a numerator divided by denominator is equal to a numerator divided by a denominator, where these numerators and denominators are algebraic expressions, like they could be anything like 2x plus 3x plus 9x plus 1 y plus 2, so anything of this sort. So whenever you have an equation of this form, something like this, let's take an example. 2x plus 3 divided by x plus 9 is equal to 1 by 2, or sometimes even on this side you might have these kind of expressions. So when you have an equation of this form, now when you look at this equation, it doesn't look that simple like the usual linear equation, right? So you feel that don't know what to do. So the only thing that you need to do in this case is your first step should be to cross multiply. Now what do we mean by cross multiply? Cross multiply means you multiply the denominator on the right hand side to the numerator of left hand side. Similarly, you multiply the denominator of left hand side with the numerator on right hand side. So that is called cross multiplication. So in this case, what will happen in that case? 2 into 2x plus 3 will be equal to 1 into x plus 9. So that is what you will get. So in this case, 2 into 2x would be 4x plus 2 into 3 would be 6, and this side it would be x plus 9. Right? So basically, you know, what are we doing when we are cross multiplying? Now basically when we are cross multiplying, we are actually multiplying this denominator on both sides. It is the same thing. If you multiply x plus 9 on both sides. Now why are we doing this cross multiplication? To keep things simple, because every time when you have to multiply something on both sides, first you will think what I have to multiply, then you will multiply that, so it will take more time. In this case, you just know all you need to do is you need to cross multiply with the denominator on the other side. So this is what you get. Now you put all the variables on one side like this and all the constants on the other side. So you get 3x is equal to 3, or x is equal to 3 divided by 3, that is equal to 1. So x is equal to 1 would be a solution for this equation. So you see, even though the equation looked complex, but we could very easily solve it. Now, one important thing that needs to be noted here is this rule is applicable only for equations in this form, and this rule is strictly not applicable for different forms of equation. For example, if you have an equation of this form, x by 2 minus 1 by 5 is equal to x by 3 plus 1 by 4. Now, is this equation in this form? This equation is numerator by denominator minus numerator by denominator. But here we said it should be numerator by denominator equal to numerator by denominator. So in this case, this rule will not be applicable. So you should not start cross multiplying here. So this will not be applicable for this case. However, if you have an example like x minus 1 by 2 is equal to x plus 1 divided by 12. So here you see it is in the same form, numerator by denominator, numerator by denominator. So here this rule would be applicable. So you can directly cross multiply. Again, let's take one more example. 6x plus 1 divided by 3 plus 5 is equal to x minus 9 by 2. So in this case, on the right hand side, it is in the form of numerator by denominator. But on the left hand side, it is not in that form. Here you have numerator by denominator plus a number. So therefore, here also overall the rule will not be applicable. So with these examples, what I am trying to tell you is where exactly can you actually apply this concept of cross multiplication to solve the equation. So now you might say that, okay, fine. So we will be able to apply this concept only where this particular form holds true. But what about all these complex forms? Because even these look more complex. So how are we going to solve them? So how are you going to solve these complex equations? So let's say whenever you have equations in the form of numerator by denominator plus numerator by denominator is equal to numerator by denominator. So when you have something of this form, in that case what we do, we multiply both sides by LCM of denominators to get an equation in linear form. So things will become clear only when we take an example. So first of all, let us take an example in this form. Let's say x by 2 minus 1 by 5 is equal to x by 3 plus 1 by 4. So let's say this is our equation. So this satisfies the form. Okay, fine. Now let us try to find out the LCM. Now what would be the LCM of the denominators? What are the denominators here? So here the denominators are 2, 5, 3, 4. So if you find out the LCM of 2, 5, 3, 4, what would be the LCM? The LCM would come out to be 60. Just try to find out LCM of 2, 5, 3, 4. So you would get something like this. So 2 into 2, 4 into 3, 12 into 5, 60. Therefore, the LCM would be 60. Now what you do? Multiply both sides by this LCM. So that means x by 2 into 60 minus 1 by 5 into 60 is equal to x by 3 into 60 plus 1 by 4 into 60. So we have multiplied everything, both the sides by 60. So this would be 2 into 30. So this would be 30x minus this would be 5 into 12, 60 minus 12. This would be 3 into 20. It would be 20x plus 4 into 15. So this would be 15. So now again we follow the same thing. Collect the variables on one side. So it would be 30x minus 20x is equal to 15 plus 12. Or we can say 10x is equal to 27. Or x is equal to 27 by 10. So x equal to 27 by 10 would be a solution for this equation. So here you see what the only thing that we need to do is first we need to find out the LCM. So once we have found the LCM, then the entire work becomes very, very easy. So these are the tips that you need to remember. So looking at the equation, first you need to decide what is the form of that equation, and then accordingly you have to take the first step. So let's look at an example of one of these equations. So let's say you are given an equation like this: n by 2 minus 3n by 4 plus 5n by 6 is equal to 21. So this is of which form? Type 1 or type 2? So this is of the form type 2. So here we'll apply our tip 2. So in that case what we do? We have to find out the LCM of the denominators. So here the denominators are 2, 4, 6. So this is how we find out the LCM, and the LCM comes out to be 12. 2 2s are 4, 4 3s are 12. So now multiply both sides by 12. So our next step is multiply both sides by 12. So this would be n by 2 into 12 minus 3n by 4 into 12 plus 5n by 6 into 12 is equal to 21 into 12. So this is 2 6s are 12, so this is 6n minus this would be 4 3s are 12, so this is 9n plus 6 2s are 12, so this is 10n is equal to 21 into 12. So we keep it as it is as of now. So now this side we solve, it becomes 16n minus 9n is equal to 21 into 12, or this becomes 7n is equal to 21 into 12, or n is equal to 21 into 12 divided by 7. So 7 3s are 21. So this would be 12 into 3, that is 36. So x is equal to 36 would be a solution for this equation. So you see, solving them is pretty easy. You just need to understand which concept or which process you need to apply. So let us now look at some of the questions of these forms. So let's look at question number 1. Solve x minus 5 divided by 3 is equal to x minus 3 divided by 5. So this equation belongs to which form? Type 1 or type 2? So which tip are we going to apply? Tip 1 or tip 2? So this is going to be applicable for tip 1, because here we have it in the form of numerator by denominator equals to numerator by denominator. So what will we do here? We will simply cross multiply. So let's cross multiply. We get 5 into x minus 5 is equal to 3 into x minus 3. So this becomes 5x minus 25 is equal to 3x minus 9. Or we can say 5x minus 3x is equal to minus 9 plus 25. Or 2x is equal to 16. Or x is equal to 16 by 2. So this is equal to 8. So x equal to 8 is the solution for this equation. Question number 2. Solve m minus 1 by 2 is equal to 1 minus m minus 2 divided by 3. So this equation obviously goes to type 2, because you have numerator by denominator plus numerator by denominator of that form at least. So that plus can be replaced by minus. So all those things are fine, but it is in that form. So here we will have to take the LCM of the denominators. So LCM of the denominators would be equal to 6. So now we multiply both sides by 6. So m into 6 minus m minus 1 by 2 into 6 is equal to 1 into 6 minus m minus 2 by 3 into 6. So therefore what do we get? We get 6m minus 2 3s are 6. So this would be 3m minus 1 is equal to 6 minus 3 2s are 6. So this would be 2 into m minus 2. So here it becomes 6m minus 3m plus 3 is equal to 6 minus 2m plus 4. Therefore, we will put all the variables on left hand side, that is 6m minus 3m plus 2m is equal to 6 plus 4 minus 3. So this would be 6 plus 2, 8m minus 3m, that is 5m is equal to 10 minus 3. So this would be equal to 7, or we can say m would be equal to 7 by 5. So m equals to 7 by 5 would be a solution for this equation. Question number 3. Solve 3 into 5z minus 7 minus 2 into 9z minus 11 is equal to 4 into 8z minus 13 minus 17. So this is pretty much simple. So all we need to do is we just calculate the values. So 5 3s are 15z minus 21 minus 18z plus 22 is equal to 32z minus 52 minus 17. So again the same thing, let's first bring all the variables on one side. So 15z minus 18z, and from here also we will bring minus 32z will be equal to minus 52 minus 17 minus 22 plus 21. So let us solve this. So this would become 15z minus 50z is equal to this entire thing would be equal to minus 91 plus 21. So this becomes minus 35z is equal to minus 70. Or we can say z is equal to minus 70 by minus 35. So 35 2s are 70, minus minus will cancel out. So we will get 2. So therefore z equal to 2 is a solution for this equation. Solve 0.25 into 4f minus 3 is equal to 0.05 into 10f minus 9. So this is also pretty simple and we will start solving it. So 0.25 into 4 is 1. So this is 1f minus 0.25 into 3 is 0.75 is equal to 0.05 into 10 is 0.5f minus 0.05 into 9 is 0.45. So therefore this is 1f minus 0.5f is equal to minus 0.45 plus 0.75. So 1f minus 0.5f would be 0.5f. This equals to, this would be 0.3, or we can say f is equal to 0.3 divided by 0.5. So this point will get cancelled. So we get f is equal to 3.5 would be a solution for this equation. So let's solve this equation now. 9x divided by 7 minus 6x is equal to 15. So this equation belongs to type 1. So we can directly cross multiply here also, because you have it in the form of numerator by denominator equal to numerator by denominator. So this would be 9x is equal to 15 into 7 minus 6x. So therefore we can say 9x is equal to 15 into 7 is 105 minus 15 into 6 is 90x. So let's bring the variables on one side. So 9x plus 90x is equal to 105, or we can say 99x is equal to 105, or x is equal to 105 divided by 99. So 333, 335. So by 3 we have cancelled both of them. So therefore we get x is equal to 35 by 33. So this would be a solution. Question number 6. Solve 3y plus 4 divided by 2 minus 6y is equal to minus 2 by 5. So here again this is in the form of numerator by denominator equals numerator by denominator. So we would cross multiply. So we will get 5 into 3y plus 4 is equal to minus 2 into 2 minus 6y. So therefore we get 15y plus 20 is equal to minus 4 plus 12y. So let's bring all the y's together. So this would be 15y minus 12y is equal to minus 4 minus 20. So this would again be 3y is equal to minus 24, or y is equal to minus 24 divided by 3. So this is equal to minus 8. So we get y is equal to minus 8. So that would be the solution for this equation. Question number 7. Solve 8x minus 3 divided by 3x is equal to 2. So in this case also, when you look at its form, it is of the same form. Numerator by denominator equals numerator by denominator. So here also we would cross multiply. So when we cross multiply, what do we get? This gets multiplied with 1, because 2 is basically 2 by 1. So it would be 8x minus 3 is equal to 2 into 3x, or 8x minus 3 is equal to 6x. Let's bring the x's together. So this would be 8x minus 6x equal to 3, or 2x equal to 3. Therefore x is equal to 3 by 2.
I hope you enjoyed the video. In the next video, we are going to learn about applications of linear equations, and that's like super duper important and interesting as well. So be with us.